Hello guys, welcome back. We are on MoBileMaThS with Try. Today we are looking at Indices 2. Okay, so we are going to use the laws that we introduced in Indices 1. So today I'll be mainly looking at some examples. Okay, so we are going to use law number 1 that is written there. This one. So an example, I've got a to the power of 6 times a to the power of 4. We said whenever we have the same base, we add the powers. So we have a to the power of 6 plus 4. And what do we get? We get a to the power of 10. Let's have another example. We also have the same base here, x. So x to the power of 7 times x to the power of 1. We have x to the power of 7 plus 1. What do we get? We get 8x to the power of 8. Okay, let's look at another law number 2 where we have division there. So when we have division, we said if we have division and the same base, we simply subtract our powers. So we are going to do the same, though this time around I've got 12 and 4 there. They shouldn't confuse you. So what we do is you take the numbers on their own and then you take these on their own. Okay, so I'll have 12 over 4 on its own. Then I have this x to the power of 7 divided by x to the power of 3 on its own. So I'll look at it in the same way that is above here. Okay, so I'll have let me change my color. I'll have x to the power of 7 minus 3, like that. Then if I have such a number, 4 into 4 4 into 12, I get a 3, sorry, a 3. Okay, so 7 minus 3, I get a 4 there. Okay, yes, I get a 4. So I'll have my result is 3 times x to the power of 4. That's my solution. Let's look at another example. This one also has got numbers, so don't confuse. When we have numbers, you treat them numbers on their own and indices on their own. So we'll have 4 divided by 4 times x to the power of 6 minus 1. 4 into 4, 1, 4 into 4, 1. So we have got our result is x to the power of 5, like that. Okay, let's look at another law where we said law number 3, any number raised to the power of 0, we get 1. So here we've got different bases. We've got a and b, but because this one is raised to the power of 0, it becomes a 1. So I'll have a to the power of minus 9 divided by, sorry, this is divided by 1. Okay, so this I'll ignore and I'll remain with this part there. Okay, so remember we said from indices 1, any number something, we write it as 1 over a to the power of 9, like this. So this becomes our solution. Okay, let's move on to the next one, law number 4. Okay, law number 4 is saying x to the power of minus a is equals to the one that I just did above there when I was solving a to the power of minus 9. Okay, so let's look at our example. This one, because we've got a number there, we still treat it the same way as our law number 4. So everything is going to be 1 over 3 to the power of x, and we still have our 3 at the end of the day, like this. Okay, don't forget it. So if I say 3 to the power of 3, what do I get? I get 27. So I'll have 1 over 27. X to the power of 3, I get x to the power of 3. So this is my solution here, like that. Let's look at another example. This one is different because the negative power is on x minus 3 only. So I'll have, if I do my law number 4, I'll get 3 over x to the power of 3, like that. hope it's clear. Let's go on to the next law, number 5. Law number 5 is multiplication. So I'll simply go straight to the example. D to the power of 4 raised to the power of 3. Okay, I'll get, we said whenever we have multiplication, we simply, okay, in this case, it's going to be different because of the bracket. So we'll multiply the powers. So I've got D to the power of 4 times 3. I'll get D to the power of 12. Okay, I'm done. The next one, 3 to the power of minus 2. So what I do here is I can even multiply these powers directly than using law number 4. So I'll have 3 to the power of minus 2 times minus 2. So these powers are negative. These powers are negative, negative. Whenever we have negative times negative, we get a positive. So we'll get 3 to the power of 4. Okay, so if we have 3 to the power of 4, we get 81. So that's our final answer there. Let's move on to the last question there. So the last question, we have got f to the power of 0. F to the power of 0. So maybe let's expand it. F to the power of 0 times 8. What do we get? We get f to the power of 0, and we said any number to the power of 0 is 1. So that's our final thing there. Let's look at law number 6. Law number 6 is this one of square roots. Let's look at it. Examples, we've got 4 times that. So I'll have my 4 times this one. Because of negative there, this negative, I'll start off writing it using law number 4. 1 over 4 to the power of half. Okay, so when it's like this, now I can find the square root. So I'll have 4 times 1 over square root of 4. Okay, I can even write the 2 if you want. It's the same thing. So I'll have 4 times 1 over 2. And 4 times 1 over 2, what do we get? We get a 2. So our final answer there is a 2. Let's look at the next example. The next example is of 8 to the power of 1 over 3. Okay, so we do the same. We will have our square root of 8. In this case, our denominator is 3, so I'll get cube root of 8 there. Cube root of 8, we get 2. Okay, let's look at the last law, number 7 there. Okay, this one, we've got A over B. We've got A over B there. Don't be confused, it's the same thing. So when we have A over B, regardless of negative, we simply solve it the same way. So here, I want to remove the negative first. So I'll have 1 over, then I have 2 over 3 like this. Whenever we have a negative, you say 1 over everything, then the negative sign disappears. Okay, so then it becomes 1 over cube root of 8, then I square that like that. Okay, then cube root of 8, I said I get 2, so I have 1 over 2 raised to the power of 2, we get 1 over 4. So that's our final thing. Otherwise, if you have any questions, if you have no questions, you can have a look at some of these examples. They shouldn't confuse you. Where we have negatives, you simply have to first of all deal with the negative signs first, then you look at the other parts later on. Okay, don't be confused. Otherwise, I wish you well, guys. Let's meet in indices 4. Thank you.